Okay. Firstly, I would like to greet each one of you who have joined today's conference. I would like to take a moment to thank each one of you for taking your time out to join the JKIN World 2023 conference. So today, the topic of discussion is all about the machine learning bound anomaly detection and the experiences that it has to offer beyond the commodity observability in the world of cloud technology. So I am Sumana Rao, working as a senior software engineer at IBM Cloud Bangalore. So I have around 5+ years of experience as a DevOps and SRE engineer with hands-on experience on public cloud platforms like Microsoft Azure, IBM Cloud, etc. Feel free to connect with me over LinkedIn. So I would like to brief you or walk you through today's agenda. I would like to kickstart by discussing about the cloud native adoption, what's the current trend and scenario in the market currently, and would like to highlight a couple of challenges that we in the developer community would come across to build or achieve scalable and high availability systems. So proceeding with our discussions, I would like to bring about what could be a robust approach to resolve such challenges. So one thing that I could think of is about machine learning to build a robust observability and alerting system. So I would like to walk you through one of the specific tool that is called anomaly detection, which is basically a feature which is backed by ML capability in the ELK stack, which is a monitoring and logging tool. So I would like to go a bit in depth about this feature to discuss what it is about, how it works, and show the results of one of the POCs that I came up with for log entry anomaly detection. So in the end, I would like to conclude the session by discussing a couple of pros and cons of this feature. Okay, so I guess we are good to start with the main discussion. So the cloud native adoption as such doesn't require any special note or any special introduction these days. So we all have experienced the difference or the efficiency that we see with the product that are hosted on cloud from that of the ones that are still not are not adopted with the cloud technology yet. So as we all know, the cloud adoption is so pervasive these days that it has touched almost all the sectors in the market. It ranging from e-commerce, finance, what else? Even for the matter, energy sectors, and also the military and defense. So even the Gartner VP also states that there is no business strategy these days without the cloud strategy. So even in fact their own analysis shows that by 2025, around 95% of the new digital deployments would be on the cloud native platforms, whereas I think around 2021 it was just around 30%. So you can just see it's just like spreading like a wildfire across the organizations. So so I would like to also discuss as in so most of us would already know that microservices based architecture is more prevalent when the cloud adoption happens. So let's see, why is it that monolithic is kind of taking a downtrend and microservices archetype of architecture is taking over the industry. So first and foremost, the goal of any service provider would be to reach as many customers as possible. So they would strive hard to make sure that the whole of the application is scalable. So that is something the microservices would really enable them to do. Then the second thing is, as we all know, the microservices are more independently functioning. So detection of which microservice is faulty in given system in case of any outages or any faults, it is easy to detect such failures, isolate them, fix it, and join them back to the system with the appropriate backup plans. So this helps in providing or making the whole of the system more resilient. And also, it goes without saying how important it is for the product to reach the customer at the right time. So this type of architecture helps to release the product or make the product reach the customer at a quicker pace. So this also comes with added advantage of getting earlier feedback from the customer, and also gives the rooms for continuous improvement. So this helps in improving the business agility as a whole. So last but not the least, I can't stress more upon the importance of data security and the compliance rules that has to be applied to any given application. So the microservices kind of architecture helps it more effective and reach every nook and corner of the product to make it more secure as much as possible. So every good thing or a great power comes with greater responsibility, and I would also add it also come with greater challenges. So I would like to discuss a couple of challenges that would come on the way, especially for the development community here. The first thing would definitely be, the efficiency matters a lot, no matter what. So this can be affected by how well we have our alerting systems or the monitoring system to make sure that the product is always up and running with minimal or no outages. And also, how are we going to maintain the product? How easy can we make the whole system to be managed? So all these things could be one of the major barriers or the challenges for to build a scalable, easy maintainability and also high availability systems. So I would like to also state one of the the case studies or one of the incidents that shows how important it is to have a stable and also high available system. So recently, I think most of us would know about one of the outages that affected huge customers, which were hosted on AWS platforms like Netflix, Spotify, etc. So the outage was for a couple of hours, which happened due to some network configuration error during the maintenance window. So this had its own chain reaction, which impacted most of the AWS related infrastructure. So all these outages are really expensive. So one of the Gartner studies also states that the average cost of an outage can anything be around $5,600 per minute. So just imagine if it goes on for hours, it can cost up to around $1 to $5 million, which is a huge loss for the cloud providers, or for that matter, even the consumers who use it. So moving on to the solution, or what could be the approach that we could take proactively to bring down such outages. So one of the ways, or one of the key ways to combat such issues, is to have a robust monitoring and alerting systems. So this helps in making sure that the failures or any anomaly that can be detected at an early stage than waiting till the system to fail. So such proactive measures helps to bring down the customer incidents and make sure that the stability of the whole system is maintained. And also having such proactive measures or setups included or adopted as part of the implementation can bring down the CIE rates up to 15%, which is a huge number. So that could not only keep the system safe, but also help in increasing the trust from the customer and also the customer experience. So, okay, so now proceeding, what could be the approach to build such a, to adopt such a proactive measure. So one thing that I could think of is adopting the machine learning capabilities to build an appropriate, alerting mechanisms would bring in more automated and intelligent system. So of course there are existing monitoring tools which would take the static thresholds into consideration and flags off if something if the stuff reach the threshold, and there would be alarms or alerts that gets triggered. But this might not be efficient when the system is dynamic. Say you have especially in the scaled system, the real-time events or the data is always dynamic and huge. So having a static threshold might not be accurate. So machine learning intelligence can help us to identify such patterns dynamically and setting the threshold appropriately to detect this acceptable behaviors, basically. So this can be enabled by adopting certain machine learning algorithms, and which helps the whole system as such to mature over time. So one of the tool that I would be discussing today is the ELK, which is the Elasticsearch with Kibana, which basically utilizes this anomaly detection feature of which is backed by the machine learning intelligence into it. So even much before diving on to the anomaly detection concept, I would like to give you a brief about the ELK stack. So ELK stack is, as I mentioned, it's a monitoring and alerting system. So which has its own submodules, basically. So the data collection happens using a data shipper called Beats, so which just consumes and just collects all the raw data from different systems and passes it on to the buffering queue. It could be Redis, Kafka, or RabbitMQ, which then becomes an input for the Logstash subsystem, which basically consumes the ingested the data. It aggregates and processes it and then sends it to the required destinations. And at the Elasticsearch end, all the indexing happens, which helps in further analysis and makes the whole of the system too easy for the consumers or the users to search based on the indexes. So the Kibana is nothing but the visual form of the Elasticsearch, so which helps the whole of the data to present it in a better human readable form. So this is just a small gist of what exactly the ELK stack does. Moving on to the anomaly detection. So the anomaly detection as such is okay. Let's see what exactly is anomaly. So anomaly is nothing but something. It's a trend or an event that is deviating from the usual set of events or a set of population around or the peers around it. So this is largely classified into two types. One thing is the temporal and other thing is the population type of anomaly. So in the temporal type of anomaly, there is something unusual that gets detected, which deviates from the usual trend that has been seen over time. So if you so just to give an example, you see that you kind of get a stream of data from a consumer, and suddenly you see a dip in the log entry rate. So this could signify that there is some kind of breakage in the system or disconnect in the system, which has led to this disconnect in supply of the logs. So this could be a proactive measure that has to be taken from the ops or the developers end to go and rectify if something has gone wrong with respect to the connectivity or the whole system as such. So the second type of anomaly is called population anomaly, which gets detected if something deviation of the usual peers around in the given set. So in order to illustrate an example, say there is a set of access group who are there are set of users who are part of an access group, and they are allowed to access a system, and suddenly the monitoring system detects a specific user who is not supposed to log in or access to the system. So this could signify that there could be a potential threat or say compromise in the data in the system security. So all these anomaly detection helps in flagging of such incidents at an early stage so that it can be rectified as soon as possible. Okay, so I would like to give you a gist of how or what exactly happens in the back end of the elastic security system. So the heart of whole of the anomaly detection is nothing but the detection engine over here. So which would get stream of data from different systems like servers, firewalls, or proxy servers, etc. So all these stream of logs are then stored into a data store, which acts like a input to the detection engine. So basically, detection engine periodically or automatically detects any kind of suspicious activity, be it on the network end or any host end. So this is enabled from different systems like the detection rules, the detection alerts, and the anomaly detection jobs that it offers. So the detection rule basically periodically checks the given data stream for any kind of suspicious access or suspicious behavior, and then sends such alerts or signals the detection alerts data, which in turn notifies the stakeholders using email, Slack, or even for that matter, the concerned team would get paged out through the pager duty. So there could be chances that there are chances of false positives or false negatives. So we still have room to go manually flag it as an exception, and in turn the detection rules gets updated. So if you see the cycle, as and when the system matures and it gets to deal with more and more data, the whole of the system becomes more fine and refined and also granular when it comes to the analysis using the detection rules. So this basically matures over time. In turn, the whole of the resultant outcome would be more granular and refined when it comes to the alerting of any kind of anomaly. So moving on, I would like to just simplify it and explain in simple terms, as in what exactly and how exactly the anomaly detection works as part of ELK stack. So for any system, we would have an input and an output, which is processed as part of a specific say process or an intelligence, which is usually a black box. So anyways, so coming to the input part of the anomaly detection. So basically anomaly detection works based on a live stream of data that is ingested by time series data, which are in turn grouped into the discrete time units called buckets. So these would be the major input for the system, which gets processed as part of models. So basically, a model is nothing but a detection function that we choose. It could be, say, average or a sum. And then it calculates the probability distribution on each of the bucket, and it is basically a continuous process. So once this is done, based on the probability distribution results, this each data point is given a score. So if the score is low, it means that that particular data point or an event has to be flagged as an anomaly. So in order to, so this is basically, you can consider it as a brain of the whole system, but this has to be enclosed, or it has to be executed somewhere, which is the duty of the ML nodes. So basically, the ML nodes help in, running the anomaly detection job. So, and also it helps in making sure that the state of the models are in turn saved as part of its memory, but it also would be mandatory to sync the state of the model to the Elasticsearch. So the main reason for this is that, say in case there is some unforeseen incident that has happened, and you would want to roll back to the previous state of the model, and then use or run the system normally going forward. So that's the reason the state of the model has to be synced with that of the Elasticsearch. And the other output of the whole system would be the alerting. So once the models flags an data point as an anomaly, it immediately goes and alerts to the required stakeholders through APIs. So the another noteworthy point I would like to share here is the algorithms that goes behind the anomaly detection model is based on unsupervised learning, which means that the algorithm need not be trained by any external entity. It has the capability to perceive the data and train itself as and when it deals with different type of data and different volume of data. So this is basically a very big win for those who are looking for such capability, wherein they want to bring down the human intervention and want everything or most of the things to be done by the automations. So, okay. So till now, let's just summarize what we have just discussed about. So the first thing that we discussed is about the challenges for the developer community to build a scalable, high availability, and stable system. Then we went through in brief about what is ELK stack, and then we discussed about anomaly detection and its types, and then we discussed about the elastic security of workflow, and discussed what exactly or how exactly the anomaly detection in ELK works. Going a bit further, I would like to discuss what is it that ML the anomaly detection models is so different or powerful in the whole system. So basically, it has three important functions or the features that makes it so powerful. So the first thing is called detrending technique. So basically, the ML models automatically figures out what is the trend in the given data set. So as and when it gets the data set, it has the intelligence to figure out what's the trend in the given set of data. So it could be, say, linear, shrinking, or seasonal or cyclic. So this helps in figuring out or making the essential modeling, especially when the data is huge and it is dynamic. So the second intelligence that it possesses is to split the job based on the categories. So in order to give you an example, say you have a set of data which can be made publicly available. There could be there could be set of data which has to be confidential, and other set of data which has to be restricted to specific users. So it has the intelligence to split up or create separate jobs for each of these kind of categories and apply the analysis, so that this helps in making the analysis specific to the data set. And hence the whole of the resultant outcome would be more specific and also in a more granular form. And the third intelligence that it has is detecting what exactly is the trend in the given data set. exactly, or what is the field that has caused the the breakage, or say the anomaly. So to give you an example, say one of the outages or one of the anomaly was due to a network glitch. So so the data set has a field called, say, the network status. So it would have the intelligence to figure out that the specific field, that is the network status, was the one that caused the failure or the anomaly. So in turn, this helps in figuring out, or jumping into the root cause of any kind of outage or any kind of anomaly that has influenced the issue. So yeah, so this was all about the anomaly detection model capability that has. So moving on to the capabilities of the jobs, so which gets executed as part of the ML nodes. So based on different user requirements, it gives us the flexibility to create jobs by ourselves. So say, for example, I'm interested just to monitor a specific field called, say, the log entry rate. I want to just see if the log entry or the set of incoming data to my Elasticsearch is constant or is uniform. So I would just focus on one single entity, so that a single metric jobs would suffice. Whereas there could be other requirement wherein I want to monitor two or more set of fields or entities. So for that, the multi-metric jobs will have to be created. So likewise, I want to monitor a specific population or a specific category or set of data to make sure that any intruding or something that is different from the peers is not detected. So for that, I would have to go and create population specific jobs. And the last one is the categorization kind of a job. So basically, I would want to monitor specific each and every category and apply some kind of operation. Say it could be some average, sum, or for that matter, any rare function has to be applied onto the category specifically, and flag out if there is any difference in the trend of the outcome or the resultant value of such operation. So these are the main capabilities that the ML jobs has to offer, and gives us the flexibility to choose one or more of them to implement for our anomaly detection system. Okay, so I had come up with a POC to create a job for one of my sample application, which I wanted to, keep a tab of the ingested data rate from that specific sample job. This particular job was created to monitor the log entry rate, basically. So as I already mentioned, it just is interested, or it just focuses on one single entity, that is a log entry rate. So this would amount to, and this is nothing but a single metric job that I had created. So I would like to share the result of it. So this is the anomaly dashboard that you see. So for each of the anomaly that it detects, it would compute the anomaly score for each of it, and also give me which category it was detected for and when was this detected. So so let me just deal with the first one now. So the score of the anomaly score is 35 for this. So FYI, the anomaly score ranges from 0 to 100. So all the scores which are nearing 100 means that it is a big anomaly. It means that the occurrence of that trend has been more frequent than the others. So so this means that the anomaly score is higher here. It means that it has repeated time and again. So let's discuss what is the anomaly, or what is the deviation that it has experienced. So it says that for a specific category that you see in the bold text. In this category, the log messages have increased by 6 folds than the usual trend. So what it could signify is the amount of users that are using this specific application at a given point in time has increased. So in case if it was flagged out to any ops team, they could just go back and check if the provision resources are enough or sufficient to cater the needs of such huge or increased customers. If there is any lacuna of the resources, they can go back, proactively add the resources, and make sure that the outage percentage or the probability of the outage is brought down. Okay, so I would like to conclude today's session by just highlighting a couple of pros and cons of the system. So the firstly, as we have discussed, it would help largely in detecting the problem beforehand or at the early stage than failing towards the end. And also it helps in improving the security of the product as a whole, because it has the ability to detect or identify any suspicious activity quickly. And the third, all these things would definitely impact the customer experience and the service, which would definitely improve the whole of the system. And the last but not the least is it helps to build a system wherein the human intervention is almost nil or least. This basically just monitors the system all the time for us. So even though it has all the good things, we have spoken or seen all the good things about it, it does has couple of downside for itself. So first thing would be, even though we have provision to flag certain false positives and negatives, still there could be traces of the false positive and negative results that could cause unnecessary pager duties or alerts. So the second drawback is it doesn't have the intelligence to grasp or segregate relevant data from the irrelevant data. So what happens is it considers every given data that it receives, it could be noisy or irrelevant data, and it goes ahead and processes it. So the last one, and also that could be something that has to be thought through, is the computational resources that it would require. It could be, say, the ML nodes or the agents that has to be configured to run the jobs would be an add-on cost or add-on resource to build the system. So considering all the both the pros and cons, and based on the user requirement, it would be it would be good to take a conscious decision to build the required proactive system to make sure that we have the early detection capability in our system that could not only build an efficient system but also help the customer to use the given product all the time with minimal or no outages. So this is all I had for today. Hope this was informative. So feel free to ask any questions or queries. I would be glad to address them.